Physics, chapter number 3, Force and Pressure. Okay, children. So, in today's topic of chapter Force and Pressure, we are going to see balanced force. Okay. In previous few of the classes, we have seen force, what is force, definition of force, then types of forces, and then we have studied contact and non-contact force, or all the type of forces like elastic force, muscular force. There are a lot of forces. Out of that, main type of forces we have seen, and we have differentiated in contact force and non-contact force, why they are coming under contact force and why they are coming under non-contact force. Now just consider, if on one single object many forces are acting. Okay, suppose we consider box. This is box, okay, kept on the floor. Now this box is heavier. Just consider that this is one of the force acting on this object. On this side also we can apply force, on this side also and this side also. So what my point is, if more than one force is acting on object, then which force you will consider, or what will be the action in that force? So it's very simple. The action will depend on the net force. Net force means there are forces acting on the box. Suppose two directions. One direction, two direction. This may also one of the direction. Okay. This may also be one of the directions. Means, just imagine this is the box, huge box. In this direction force is being applied. In this direction force is being applied. In this or like this. Okay. So this is what, not one single force is here. What effect we will get? That effect, or how much force will be acted on that particular object, will be due to net force, or I can call it as resultant force. Okay. Or I may also call it as total force. Okay. Or effective force. Effective force means effective force, resultant force, or net force means what is the effect on that particular object. Okay. Now before that, we have just seen the general idea of force, different types of forces. This thing, children, you already studied. Okay, force. Then in previous classes we have studied different types of forces: muscular force, frictional force, electrostatic force, elasticity force, elastic force. So these are different type of forces. So if I am talking about net force, resultant force, or effective force, then this force is having certain quantity. Okay. So it will have its unit also. Means if I am applying force in this direction, that means I have to represent some amount of it, or whatever amount is being used, that will be measured by using SI unit. Okay. Or you can use CGS unit. So force SI unit is Newton. Okay. And its CGS unit is Dian. Okay. Newton you write by writing it capital N, but well, if the unit is in CGS system, you have to write Dian. Don't make it capital D or small d. Okay. It should be D-Y-N-E, Dian. And Newton, if you write N, that means its unit is, we know that its unit is Newton. Okay. So if the value is 5 Newton, or if I don't write force, I write only 5 Newton. So you will come to know that this given physical quantity, this given quantity is of force. This given quantity is of force. How much force? 5 Newton. Okay. Now, let us see now here in the directions given, sorry, F1, F2, F3. Okay. So, these forces are applied on this box. Suppose F1, just now we have observed, let us take it as 5 Newton. Okay. F2 is 2 Newton and F3 is 3 Newton. Okay. So, here the values of applied force is given to you. Means, in this direction on the box, 5 Newton of force is applied. Okay. In this direction, 2 Newton and 3 Newton of forces are applied on this box. Okay. What I am asking, what is the effective force or net force or resultant force? Okay. So you will come to know that whenever we are talking about force, effective, net force or resultant force, that means addition of all the forces. Okay. Let us see. This is how much? F1 plus F2 plus F3. How many values we are having of forces? 3 values. F1, F2, F3. Okay. Now, this F1 is 5 Newton. But, children, the amount is 2 Newton, but its direction is opposite. Force direction is opposite. Okay, it's directional quantity. It is directional quantity means with its value, it also tells the direction. Okay, now just see. This is 5 Newton. This is minus 2 Newton. Why I have written minus 2 Newton, children? Because this 2 Newton is in the opposite direction of 5 Newton, or I can say F2 is in the opposite direction of F1, and whenever we are representing physical quantity with opposite directions, then they are having different sign. Different sign means positive and negative. Like you are having axis, okay, this side is positive and this side is negative. Okay, so definitely this is the direction of force F1 and these are the directions of F2 and F3, that is opposite to F1. Hence, this is minus 2 Newton. Why minus? Negative sign? Because of its opposite direction. Okay, plus. Okay. F3 is again opposite to F1. Hence, minus 3 Newton. Now, let us solve it. 5 Newton plus minus, minus 2 Newton plus minus, minus 3 Newton. So, it becomes 5 Newton minus 2 Newton becomes 3 Newton. Minus 3 Newton plus 3 minus 3 comes 0 Newton. So here force is how much? Net force or effective force or resultant force is 0. So what I say that no force is acting here. That means this box will not move its position or it will not change its position or the box will not move. And when this condition occurs that there is after application of force, the object is not changing its position, object is not moving from its place, then that force is what? Balanced force. That force is called as balanced force. It is balancing what? These forces are balancing, which makes net force to come 0. And whenever net force, effective or resultant force comes 0, then that particular force is balanced force. They are balancing to each other and not allowing the object to move, or I can say not allowing that object to change. Okay, so we have seen various changes. We children stretching, twisting, all these we are doing different action. So this force is said to be balanced force. Okay, in this particular example. Now let us consider another box. Okay children. Suppose from upward direction 10 Newton of force is being applied, and from downward direction 20 Newton of force is being applied. Okay. Now see, let us consider the box. Okay. And we are applying force in downward direction. How much amount? 10 Newton. And from, or I will consider this as F2 and this as F1. Okay. And in upward direction 20 Newton of force. Now it's very simple children, that here we are having lesser force as compared to this force, means F1 is greater than F2. So by how much? By 10 Newton. By how much? What is the difference? 10 Newton. So it's very obvious that this object will move in which direction? Upward direction. This object will move in upward direction. But when it will move in upward direction, I want to know how much actually force is being used here. You can see that out of 20 Newton, 10 Newton will balance with F2. From F1, out of 20, 10 Newton of force will balance this 10 Newton. How much is left? 10 Newton. So how much will be the effective force? 10 Newton. And this object will move in upward direction. Now mathematically let us calculate. F net is equal to F1 plus F2. So F1 is 20 Newton plus, again these are in opposite direction. So F2 is in opposite direction to F1 by value 10 Newton. So because of its opposite direction we have to take negative sign. Okay. If we are having the same direction, then we will add these two values. But here we are having opposite direction. Okay. So 20 Newton, again plus minus 10 Newton. So it comes to be 10 Newton. In which direction? In upward direction. So in upward direction, the object will move in upward direction by how much amount of force? 10 Newton. Because this 10 will balance 10, and what is left? 10 Newton. Okay. So when the object changes its position after applying force, if object is changing its position or there is change in that particular object, then that force is said to be unbalanced force. Here number of forces are being used. Okay, and we came to know that resultant or effective or net force is not coming to 0, is not equal to 0, then that force is said to be unbalanced force. Understood children? So you may see various examples. Suppose this is another. Here 2 Newton, 3 Newton, 4 Newton, 1 Newton, 2 Newton. Okay, so these are various forces. Okay, so let us see, this 2 plus 3 becomes 5 Newton, 1 plus 2 becomes 3 Newton. Okay, 2 plus 3 5 Newton, 1 plus 2 3 Newton. So in this direction 5 Newton, in opposite direction, so it's very simple, 5 Newton. In this direction, opposite to this is minus 3 Newton. Why? Because it is in opposite direction. And this, if you are taking in downward or upward direction, plus 4 Newton, whatever. Okay. So your answer will come, which will not be equal to 0. Then when certain forces are, you will come to know that they are not balancing to each other, then that forces are said to be unbalanced force. Okay. So in the next session, we'll see problems based on balanced and unbalanced. Okay. So it's very simple. If net force comes to 0, then that force is balanced force. If net force does not comes to 0, then that forces are unbalanced. They are unbalancing to each other. Hence the value will not be 0. It can be negative, it can be positive. And negative and positive will only explain the direction of that particular object. So in which direction the object is moving. Okay, so in next session